In this video, we will be solving for the sides of a composite right triangle using these formulas. So we have the big triangle on the outside, and the altitude splits it into the smaller green right triangle on the left, and this medium red right triangle on the right. If you would like to see a derivation of these formulas, here's a link to that video where we go through it in depth. A quick heuristic way to visually remember these formulas: c squared equals d times e. You can think the tent pole here squared equals the product of the two bases. For the second formula, if you think of a ball rolling down this side, we have a squared equals d times d plus e. And then for the third one, you can think the other way: b squared equals e times d plus e. Think of a ball rolling down the hill, and b squared equals e times d plus e. Not very technical, but it does help to remember them. So now let's start with our first set of variables. C equals 12 and E equals 16. We will use the first formula. So C squared equals D times E. And then 144 equals D times 16. And then D equals 9. So D is 9. Now from here, we'll do this in green. We have the left triangle and the right triangle. For this triangle, you can see if we divide 9 by 3, we get 3. And if we divide 12 by 3, we get 4. So then 5 times 3, this is a 3, 4, 5. So 5 times 3 is 15. In the triangle over here, if we divide 12 by 4, we get 3. If we divide 16 by 4, we get 4. And then we have a 3, 4, 5 again. And 5 times 4 is 20. Now moving on to the second line here, we have D plus E is 100, and D is 36, making E 64. Now again, we can use the first formula, C squared equals D times E, and we have C squared equals 36 times 64, which gives us C equals 48. Now on this right triangle, if we divide 48 by 16, we get a 3. If we divide 64 by 16, we get 4, giving us a 3, 4, 5 triangle. And then 5 times 16 is 80. We could have also used this third formula here, and we're going to do that now. B squared equals E times D plus E. So B squared equals 64 times 36 plus 64, or B squared equals 6,400. 64 times 100, and then B is 80. Either of those work. You can use the formulas up here, or you can use Pythagorean triples or Pythagorean theorem. Now over here on the left side, if we divide 36 by 12, we get 3. If we divide 48 by 12, we get 4. Again, 3, 4, 5. And then 5 times 12 is 60. We could also use the second formula here to get A. It's the same basic calculation as on the right side. Now going to the third line, we have D equals 4 and E equals 13. This time we're going to use the formulas here to get all of these numbers. So again, C squared equals D times E, then C squared equals 4 times 13, which is 52, and then C equals square root of 52, which is then 2 times root 13. So we will put 2 root 13 on the diagram. Now we will use the second formula to get A. So A squared equals D times D plus E, or A squared equals 4 times 4 plus 13, or 68. So A equals the square root of 68, and simplifying we get 2 root 17. So again, we'll put that over here, 2 root 17. And now we will use the third formula to get B. So B squared equals E times D plus E, or B squared equals 13 times 4 plus 13, which equals 65. So then B equals the square root of 65. And again, we will put that on the diagram. So now, if you want to check your work by doing Pythagorean theorem, you can use a squared plus b squared equals c squared on this side, or a squared plus b squared equals c squared over here, and it does work. We will leave it to you to check that. Next, we will go to the fourth line here. A is 15, and D is 9. So first, we have a 15 and a 9. 15 divided by 3 is 5, and then 9 divided by 3 is 3. So we have a 3, 4, 5 triangle, and then 4 times 3 is 12. Written in green because we used a Pythagorean triple rather than the formulas up here. Now from here, we could either use the first formula with C and D to get E, or we could use the second formula with A, D, and E, A and D to get E. The first formula is simpler, so we'll use that. So then C squared equals D times E, or 144 equals 9 times E, and then E is 16. So this is 16 here. Now from here, we could use the third formula to find B, or we could recognize that 12 divided by 4 is 3, 16 divided by 4 is 4, and then that makes this a 3, 4, 5 multiple, and then 5 times 4 is 20. Having done that, let's say you're on a test and you're not confident in your work. We can now use the third formula here to check that our work is correct. So B squared will equal E times D plus E, or 20 squared, which is 400, will equal 16 times 9 plus 16. And in fact, it does. So we have our check. And now we will move on to the last line. If you were hoping for something much more challenging, this is it. A is 3 and B is 4. So now if A is 3 and B is 4, then D plus E is 5. 3, 4, 5 triangle. So let's say D is X, then E is 5 minus X, and then we're going to call this Y. And then we'll use these formulas and Pythagorean theorem to get both variables. We could call this X times 5 minus X, because C squared equals D times E. That turns out to be a much harder polynomial to solve. Try it on your own if you would like a challenge, but here we will do it with a Y. So now Y squared equals X times 5 minus X. And then from this left triangle here, X squared plus Y squared equals 9. So now we're going to take Y squared here and plug it into there. And then we get X squared plus 5X minus X squared equals 9. X squared and X squared cancel. 5X equals 9. And then X equals 9 over 5. From there, we will plug back into the second equation. So we have X squared, or 81 over 25, plus Y squared equals 9. And then solving for Y, we get Y equals 12 over 5. So now putting these back into the diagram, D is 9 over 5, C is 12 over 5, and E is 5 minus 9 over 5, which is 16 over 5. So now we will do Pythagorean theorem on the left triangle as a final check. 9 over 5 squared, which is 81 over 25, plus 12 over 5 squared, which is 144 over 25, is then 225 over 25, which then equals 9, which is 3 squared. And we have our final check. Again, this last one was significantly harder, so run through it a couple times and do your checks. And that is how you solve composite triangles. As you can see, composite triangles go from fairly easy up here to significantly more difficult down here. Go through all of them several times. Chances are this last one, you won't see anything this hard on a test, but you never know. So go through it, conquer it, and move on.